Want to travel fast and light? Here's how.
The vacuum field can be described using a vacuum stress energy tensor v GB underscore mu nu y, which, similar to the energy momentum tensor for matter, governs how mass energy interacts with and distorts this negatively charged vacuum. The interaction between the vacuum and mass is not one of simple attraction. Instead, the vacuum actively responds to the presence and distribution of mass, causing both local curvature gravitational wells and large-scale repulsion cosmic expansion. Cosmic void expansion rate. In the standard cosmological model based on dark energy, cosmic voids are expected to expand at an accelerated rate due to the repulsive force of dark energy. However, in QVFD, this acceleration is attributed to the negative vacuum field, which is activated more strongly in low-density regions. Prediction in QVFD. The expansion of cosmic voids will not be uniform. Regions closer to active galactic clusters should expand more rapidly than voids situated further away from mass energy concentrations. The repulsive vacuum field will cause an inhomogeneous expansion, with larger gaps of repulsive regions between clusters and smaller, more confined regions around dense clusters. An easier way to discover the Kavetsky theory is viewing a fish in the ocean. The fish paddles his or her rear fin faster or slow and gains speed or acceleration when viewing a spacecraft in space. This three-dimensional sea is the same way we will view space. As the fish gains acceleration or velocity, it stops. This is the velocity the fish has reached. In space, it's the same way. The engines assert acceleration. Once the ship reaches the acceleration velocity, it can stop in the same manner as the fish in the ocean. The meaning of this illustration illustrates space advance, or space gravitation, as if there were a repulsive force in the body of water, the ocean, or in space that, like the Hubble expanse, is a force pushing the water in the sea or the space body in outer space at a continuous velocity. As the Hubble sphere creates a repulsive push force on the space itself, it is accelerating space. This push force is constant and retains a velocity like any moving object. This push force anomaly is measured in quantum physics to be the same force as energy is needed to make an object move even here on our planet, 2 times the mass weight of the object. With this, we can sum the push force of the sphere creating motion in space. A relative velocity used today is the speed of light. But in Hubble's era, he discovered the galaxies were being pushed away from each other at a constant rate and at a constant speed. 43 miles per second. If we use the energy analogy like I mentioned in putting an object into motion, it's twice the mass of the object we want to move. Our Hubble sphere pushes faster light, and the energy or pressure observed by Hubble as well as the amount of push force necessary. To move an object relative to its weight, we can calculate it takes twice the velocity of light to maneuver the repulsive force needed to push galaxies apart from each other. That's where we can measure the amount of pressure necessary to cause this action. But unlike our fish in the ocean, it will slow down due to the weight of Earth's gravity. But in space, there exists no measurable weight or resistance to slow our spacecraft traveling in space. So we calculate that if space is expanding due to the push force, our spacecraft will assume acceleration without accelerating more than it has already. But we also know that if our ship has the engine capacity to accelerate faster than light, it can. It is this energy pressure that creates a surfing of the runaway space environment that a ship may assume travel and at speeds greater than the speed of light. And since we have calculated the amount of repulsive energy it takes to make this happen, we can rely on our measurements that a ship having warp capacity will travel at least 450,000 miles a second per second, having reached that velocity. Voyager of the push field. The stars didn't twinkle out here. They stretched lines of white fire slashing across the black canvas as the ship rode the invisible tide. Inside the cockpit, Commander Allen watched the chronometer tick in perfect rhythm. Local time was preserved, her heartbeat steady, her breath slow, but outside, space itself moved. There were no engines firing, no ion trails, just the soft hum of the repulsive drive warping the field behind the ship, pushing against the very structure of vacuum. It was as if the vessel floated on a self-generated wave, its repulsive swell shoving the universe backwards, creating momentum by moving the medium instead of the mass. Approaching critical swell, said the Navy I. Space curvature behind the vessel expanding at 0.98 c, Hubble flow synchronizing. Ellen smiled. The old physicists had it backward. They thought nothing could move faster than light. But what if you didn't move at all? What if you bent the space behind you like a rubber sheet, pulling distance toward your destination? Alpha Centauri, 1.2 years remaining. Through the viewport, the background warped light itself refracted across shifting pressure gradients in spacetime. The vessel was a surfer, and the wave was spacetime, driven by the subtle art of manipulating the zero vacuum gravity Willow field so precise it repelled gravity itself. No resistance, no inertia, just smooth, elegant gliding through the dark. She was no longer just a pilot. She was riding the universe. Technical excerpt, repulsive push-force propulsion and superluminal travel. In advanced theoretical propulsion models grounded in quantum physics and cosmological space expansion mechanics, the concept of a repulsive push field offers a compelling framework for achieving faster than light FTL motion without violating the relativistic speed limit locally. Rather than accelerating a spacecraft through space using conventional thrust, the repulsive field mechanism alters the spacetime fabric around the vessel. This is achieved by generating a spatial swell-controlled region of space expansion behind the ship, analogous to an artificial Hubble flow. As space itself expands, it pushes the craft forward, allowing the ship to traverse vast interstellar distances without exceeding the local speed of light. Key components of this system include repulsive vacuum gradient generator RVGG, creates a low-energy anisotropic expansion of space behind the ship, simulating a directional Hubble expansion. Zero vacuum gravity field ZVGF maintains a gravitational null zone ahead of the ship, minimizing inertial resistance and preserving local time continuity within the vessel's frame of reference. Spacetime compression shell STCS, a stabilizing boundary that prevents relativistic shear and ensures that internal mass-energy systems are not affected by external spacetime deformation. The result is a propulsion architecture where the vessel remains locally subliminal, but its effective displacement across space exceeds the speed of light as measured by an external observer. Time dilation is minimized due to the field-synchronized local temporal frame, and causality violations are avoided since the ship is not violating the constraints of special relativity within its operational frame. This model reflects an alternative interpretation of general relativistic constraints, utilizing repulsive spacetime geometry akin to negative pressure solutions in Einstein's equations to engineer motion through the universe by manipulating the vacuum structure itself. Einstein's relativity defines a strict cosmic boundary, the speed of light 186,000 miles per second. Nothing with mass can go faster. But what if mass didn't move through space? What if space moved for us? All we need propulsion warp drive engines. Engines calibrated each light speed values. We can use as many of these engines as the architect makes his ships. Just buy the fastest ship available. Space will do the rest. Behind the ship, space expands pushed outward by a localized vacuum swell. Ahead, a neutral zone forms an area of gravitational emptiness. The result: the ship is pushed, not pulled forward through a field that expands faster than light. Yet, inside the ship, time flows normally. At 450,000 miles per second, a rate driven by space itself, a journey to Alpha Centauri takes just 1.76 years. Not by cheating light, but by surfing expansion. The same cosmic swell that drives galaxies apart, now harnessed for motion. We are no longer bound by rockets and resistance. In quantum physics, we've redefined motion itself. Repulsive push-force propulsion lets us ride the universe not as travelers in space, but as architects of it. 1. A spacecraft creates specific speed in space. Afterwards, space acts as the carrier force. Not more need to accelerate. Since matter and propulsion are limited to the amount of velocity it acquires, if a ship can travel faster than light, it will. Space acts as a surfboard in the three-dimensional grid. If a ship has the capacity to accelerate with warp drives or engines that are calibrated to reach light speed, and the spacecraft retains 3 such engines, it will travel 3 times light speed. Unlike relativity, quantum physics illustrates an expanse space where space is what creates the motion throughout the universe itself. As the Hubble anomaly expands, it pushes the galaxies into their orbital track. As the anomaly expands at a constant impulse rate every second, it creates a repulsive space environment. It is this pushing that causes space to accelerate in the process. Where relativity asserts a light speed limit for all matter that exists, we have to look at space itself by itself. The action of space expanding in a continuum. Within the quantum physics study, the accelerating force of space is advanced to a speed that measures faster than light. Quantum physics explains how energy and momentum, including motion, is not constricted to Einstein's speed limit but is engaged at velocity twice light speed. It is for this same reason that the difference between the two theories, acceleration and velocity, are different. It takes more energy to create a repulsive push force than it does for matter measured in relativity, measured at a universal speed limit as Einstein has imposed it. With this in mind, we can illustrate in theory how space acts as a repulsive push surfing type environment, whereby in the first 20th century Einstein shows how space can bend. Rodney Kovatsky shows how space enforced by acceleration acts like a surfboard beneath the open sea, like ocean waves push against the existing shores. The Alcubierre drive, Alcubeta Jerry, is a speculative warp drive idea according to which a spacecraft could achieve apparent faster than light travel by contracting space in front of it and expanding space behind it, under the assumption that a configurable energy density field lower than that of vacuum, that is, negative, could be created. Proposed by theoretical physicist Miguel Alcubierre in 1994, the Alcubierre drive is based on a solution of Einstein's field equations. Since those solutions are metric tensors, the Alcubierre drive is also referred to as Alcubierre metric. Objects cannot accelerate to the speed of light within normal spacetime. Instead, the Alcubierre drive shifts space around an object so that the object would arrive at its destination more quickly than light would in normal space without breaking any physical laws. Although the metric proposed by Alcubierre is consistent with the Einstein field equations, construction of such a drive is not necessarily possible. The proposed mechanism of the Alcubierre drive implies a negative energy density and therefore requires exotic matter or manipulation of dark energy. If exotic matter with the correct properties does not exist, then the drive cannot be constructed. At the close of his original article, however, Alcubierre argued, following an argument developed by physicists analyzing traversable wormhole, that the Casimir vacuum between parallel plates could fulfill the negative energy requirement for the Alcubierre drive. Another possible issue is that, although the Alcubierre metric is consistent with Einstein's equations, general relativity does not incorporate quantum mechanics. Some physicists have presented arguments to suggest that a theory of quantum gravity which would incorporate both theories would eliminate those solutions in general relativity that allow for backward time travel.